Hey kids, Smith here. Got another dimensional analysis video for you. This one's going to be using metrics and time, and it's going to have some single steps, just like the last nonsense video had. And it's also going to have some multi-steps and some what we call derived units, units that are calculated like a squared or a cubed, or units that are combined. You're very comfortable with these when you think about the speed of a car. We think of things in terms of miles per hour. So that's a combined unit. And we want to do something with that because again, these are a skill set we want to be comfortable using. And the more we use a tool, the more comfortable we get with using it. So let's take a look. Remember, just a quick review that dimensional analysis is simply a tool. That's what DA is. DA is a tool for converting units. And what we wanted to make sure we do is we want to ensure the units cancel. If the units cancel, then the problem is probably set up correctly. So we're going to go through some single and some double. Here are the steps we took. We started with identify the unknown quantity or the known quantity. So identify the known quantity. Then we set up units, set up conversion factors. And as we can set up those conversion factors, so the units will cancel on the diagonal. Could be either way. Could be could be northeast, southwest, could be northwest to southeast, but they're going to cancel on the diagonal always, right? And then we're going to perform the math. We're going to multiply and we're going to divide and we're going to report an answer that has as many digits as the least number of digits in the problem. And we saw that really created some use for scientific notation in our last video where we were doing dimensional analysis and we had to say, hey, we can only represent as many as are given. So if we only get two, we might have to put those into scientific notation. Now, just to make sure we have some common conversions, I've switched over to green. These are given, although I'm going to switch back to blue, sometimes they aren't. And most of these are metric to metric and time. So, I think you should be comfortable with most of these. You should know that 1 minute has 60 seconds. That's pretty fair. I think it's fair to think that 1 hour has 60 minutes. I think one day has 24 hours. And then we have common metric system ones as well. And these are all fairly common that 1 kilometer, we went over these in class. 1 kilometer is 1,000 meters. 1 meter has 100 centimeters. 1 kilogram has 1,000 grams. And 1 gram has 1,000 milligrams. Now, when it comes down to numbers being given in the problem, we're never going to worry about these numbers that are being given. These are exact conversion factors. This is how the metric system was set up, was this factor of 10, tens, hundreds, thousands. Those are exact conversions. So those are never going to limit how many decimal places or how many digits we can represent in our answer. So let the problem as written kind of dictate how many digits we can have. Here's what I mean. In our first problem, we're being asked to convert, here's example one, convert 3.2 hours. Excuse me, 3.2 hours, convert that to minutes. And I know you guys can get the answer. I know getting the answer isn't the problem. We want to see the setup. Please perform the setup correctly. And so we're going to write down 3.2 hours. I only need a single conversion unit for this. I want my hours to cancel. I want to get to minutes. In 1 hour, there are 60 minutes. 3.2 times 60 is 192 minutes. Again, here's my problem. I only get 2 digits, so I'm going to have to say 1.9 times 10 to the second minutes is 3.2 hours. That's as accurate as we can be. Okay. Again, this is not about getting the right answer. It's about using the right procedure. And I'm going to ask that we please show all work for credit. So it doesn't matter what's in your calculator. What I need to see is you are setting up what was given. You're setting up a T-chart, train tracks. That T-chart shows me the conversion unit with its quantities and its units. We multiplied that out. We recorded the correct number of answers and we boxed it or circled it. Show the process. Don't just get me the right answer. There are a lot of things that can get me the right answer. I'm trying to ask you to think your way through a problem. That part would be really helpful to us here. So, what if we took another metric and let's convert? Let's do example number 2. Let's use mass and let's convert 8.8 kilograms. It's going to be about, whoops, that's going to be about 20 pounds, 8.8 kilograms. Let's convert that to grams. So let's start with the 8.8 we've been given. I know, you know, we know. You can multiply it by 1,000, but that's not going to get you full credit. Okay. 1 kilogram, 1,000 grams. Every number has a unit. Now, what's strange is I'm going to get 8,800 grams. My problem gave me 2 digits. That's clearly 4 digits. So 8.8 times 10 to the third grams. These are simple one-step problems. I hope you're finding them simple. They're very straightforward. What I'm trying to do is set up my units so that if they are on the diagonal, that my units, that I've got hours here, I'm going to put hours down here, and those two things are going to cancel on the diagonal. Same thing in the bottom problem. I have kilograms here, kilograms, and those are going to cancel top and bottom, changing my units to grams. Now, let's make it a little bit more challenging. Let's increase. Let's take time. Example 3. Let's change 2.5 days into seconds. We can't do that in one step. That one's kind of hard. Sure, you could take them and multiply them all through. That's not what you're being given. And that's not going to get you full credit. Let's go sequentially, step by step, please. 2.5 days. Each day, we're going to do the same thing. We have a multi-step problem. Let's go from days to hours. Let's go from hours to minutes. Let's go from minutes to seconds. Those are the steps. So when we look at our units canceling, days cancel days, hours cancel hours, minutes cancel minutes, and we're left with a unit of seconds, which is what we're looking for. Now we got to fill in the conversion factors. 1 day is 24 hours. 1 hour has 60 minutes. 1 minute has 60 seconds. I didn't combine those. You aren't going to combine those either. 1 hour has 60 minutes. 1 minute has 60 seconds. Please, if we multiply those across the top, multiply those across the bottom, I know it's only one, you're going to get an answer that's a pretty big number, 216,000. Again, we only get 2 digits. Ew. So now we're going to have to round that number and put it into scientific notation so that it's 2.2 times 10 to the fifth seconds. We can't represent 216,000. We don't know that level of accuracy. The only level of accuracy we know with 2.5 days is 2 digits. Therefore, our answer can only have 2 digits. That's just the way it works. Okay. So one more multi-step where we're combining units together. And this one's a really good problem. It's going to combine both distance and time. So here's example 4. Whoops. In this case, suppose a cyclist, a bicycle person, rode 42 kilometers. in exactly 1.50 hours. How fast is that cyclist going in meters per second? So in this case, we have two different problems we have to do. We're going to convert from kilometers to meters, and then we're going to convert from hours to seconds. This should take us several steps. So bring the whole problem down. Don't separate this into two problems. Let's keep it as one problem. 42 kilometers. Whoops. Let's get that red. Sorry. Let's get 42 kilometers per 1.50. And now notice 3 digits on top, 3 digits on bottom. So our answer is going to have 3 digits. We should be okay here. So big conversion, we're going to have 3 steps. Doesn't matter whether you convert the top or the bottom first or second. So let's convert, whoopsie, give me that line back. Let's convert our kilometers to meters. Kilometers are bigger than 1 kilometer. There are 1,000 meters. We have to know that. That's a metric conversion. So now on the diagonal, my kilometers canceled. Now we're going to convert hours into seconds. We're going to go from hours to minutes. We're going to go from minutes to seconds. In 1 hour, 60 minutes, 1 minute, 60 seconds. Do that in 2 steps. Do not combine those time units. Okay? Multiply it across the top, multiply it across the bottom, divide at the end. This is where Texas Instruments, you can do it all on your calculator. I'm just asking you to show me what are you doing in your calculator. That's just 42 times 1,000. Yes, that's okay. Show that work. Show all work for credit. Okay? Multiply the top, multiply the bottom, divide them at the end. You get that cyclist is going 7.78 meters per second. Okay? Notice my units are going to cancel hours, minutes, cancel minutes. I'm left with a unit of meters per second. So these are multi-step problems. Keep in mind what we've talked about with time. Do not condense those units. Write your conversion factors top and bottom. Write a unit on every number. Multiply top and bottom. Get the correct answer. Record it to the correct number of digits. And then circle your answer. These are metric versions with time, and I've got a worksheet coming for you on this one. I'm Smath, and I hope this video helped you.